Swayam Prabha. Digital India. Educated India.
Okay, welcome everyone. So, today I will start with a new topic, which is also the last topic of our course in optimization. The topic is called dynamic programming or dynamic optimization. The theme of dynamic optimization is about taking decisions over time at multiple time instants, one after the other, and you optimize not just the cost at each time, but a consolidated cost over the entire time horizon that one is considering. So, as compared to optimization, in which there is one cost function that is to be optimized at that particular time, in dynamic programming you have a cost function at each time, and what we want to optimize is the sum total of these cost functions over the entire time horizon. The complications in dynamic programming arise because this is not simply a separate optimization at each time step, because the decisions you take at one time step impact the information that you have at the next time step and the decisions that you will take at the following time steps, right. And as a result of this, what one has is actually a series of optimizations that are coupled intricately with each other, where there is where decisions of the past feed into the decisions of the future. As a result of this, we have this kind of optimization requires a study in its own right. It is not merely a corollary of static optimization, and as a result we it requires some viewpoints and tools that were not that aren't actually present in static optimization. Okay. So, to motivate and to give an to explain what I mean by all this is, let us take an example. Okay, the topic for today is what is called dynamic optimization, so or dynamic programming. All right, and what is my example? My example is what is called inventory control. Okay. So, the example is of what is called inventory control. Now, inventory control really refers to the situation where you are, say, a shopkeeper or a shop owner, and he wants to decide the amount of quantity needs to decide the amount of quantity of a certain item to be ordered over some time instance, and we will say about some time instance, say 0 to n. Okay. So, these are n time instance, and you want to order quantity at each of these time instance, right, and you want to you want to determine what is the quantity to be ordered. So, now what are the considerations involved in a problem like this? Well, you want to order a certain amount of quantity. The goal is to meet the demand. Okay. So, the goal is to meet the demand, It is also to optimize costs. You may also have other constraints, such as, for example, you may have storage constraints. You may not be able to store an very large amount of quantity of that particular item. There may also be constraints of say perishability, that the item may need to be disposed of before a certain time, and so on. Okay. So what we will let us to formulate this problem, let xk denote the stock available at the beginning of the kth period. Okay. So, now so what we will do is we will be making decisions over time periods. Okay. So, and those time, but then the time our time starting from 0 to n is actually to be divided into n periods. So, this is period 1, this is the end of period 2, etc., etc. All right. This is how we will think of time. So, time for us is going to be slotted and discretized like this. So, we have to develop a convention about when exactly are we keeping track of the state or the stock available to us. Okay, the stock. So, our convention is going to be that we will keep track of the stock available at the beginning of the kth period, right. So, the stock, when we are talking of stock xk, it is going to be or say stock x3, it is at the it is going to be at the beginning of period 3, right. So, that is the so this is a convention that we will adopt. So, you could also adopt a different convention in which you take the stock at the end of the period, but our convention is going to be that it is going to be at the beginning of the period, all right. Okay. So, the stock, then let us denote UK as the stock ordered at the beginning of the kth period. Now, once again, this is again a convention. We are keeping the convention that the stock is being ordered at the beginning of the period. So, it is at the left hand point of the period, all right. And now, there, depending on the problem, you may have complications, such as the stock may take some time to get delivered once you order it. Say, for instance, you order it and it comes to you after a certain number of periods, but for simplicity I am going to assume that the stock is both ordered and it is at the beginning of the period and delivered also immediately. So, this would mean that our time periods are wide enough, so that they take into account both the amount of time that we are measuring, but also the delivery time is insignificant then, right. And let Wk be the demand for the item during the kth period. Okay. So, it is the demand for the item during the kth period. Now, demand again is not something that is not something that we can attribute to either the left endpoint or the right endpoint. It is rather a property of the entire period. But the way since we have adopted this convention, what we can say is that we can relate the stock available at the beginning of the k plus 1th period to the stock available at the beginning of the kth period and the demand during the kth period, right. So, now as a result of this, we have that x k plus 1 is going to be equal to x k plus. So, this is the stock available at beginning. This is the stock you have added or ordered. This is the stock consumed. Over the kth period. So, by the time you reach the left endpoint of the k plus 1th period, okay, by the time you reach the left endpoint of the k plus 1th period, you reach the inventory level would then be x k plus 1, okay, or the level of the stock is x k plus 1. All right. Now, we are going to assume that W's W1 these W's let us say W0 to Wn minus 1, right. Now, these W0 to Wn minus 1, these are, let us say, independent random variables. But if you are not comfortable with random variables, it is okay. You can simply think of these as some exogenous variables that we do not know the value of. So, if you now the important thing here is that W is realized, the W k is going to be realized during the period k, right. So, W 0 gets realized in this period, this is W 0 gets realized here, W 1 gets realized here, etcetera, right, and W n minus 1 gets realized here at the beginning during the nth period, okay, which starts at during the nth period or during this last period here. Okay. So, these are good. So, now because this is going to be realized during this period, when we are making this decision, okay, when we are making the decision of ordering say a quantity u1 at time 1, okay, when we are making this decision of ordering a quantity u1 at time 1 or a quantity u0 at time 0 or whatever, we are not aware at that time of the value of W that will be realized over this particular period. So, u1 has to be decided without the knowledge of W1, right. Of course, you would be aware of u0, but not the value of u1, right. So, this has to be done without the knowledge of this particular the realized demand at that time. So, this is this particular thing because this is something that so it is exogenous and its distribution we cannot control. It is what we use the word noise for this, we call this noise. Noise is simply any randomness which comes from the environment whose distribution it cannot be chosen based on actions that you take that we can take, right. So, again if you are not comfortable with probability, randomness, noise, etcetera, it is all right, but just be aware that that in solving these problems, we have to bear in mind that x k is to be chosen before the value of W k is known, all right. That is something that you have to bear in mind, all right. So, let me go to the next page then. So, So, these decisions have to be taken in order to optimize a certain cost. So, let me write out a cost function for it. So, let us say there is a cost R, okay, R of x k, and what is this? This represents, say, a penalty for holding either holding excess inventory in the, that is in the case um, uh, when x k is positive, when you have a positive amount of stock left with you, or a shortage cost. So, this is the cost, say, of unfulfilled demand. It is say some notional cost we have for unfulfilled demand. Okay. So, how does this, so in terms of a block diagram, if you want to think about what is going on here, sorry, there is another cost term which is, say, a purchasing cost. Okay. So, when every time we order quantity u k, let us say we incur a cost, say, C times u k or C of u k. The purchasing cost of ordering u k quantity of the item. Now, these are all kept simple. Of course, my R could also depend on k here, say this R here could depend on k, the purchasing cost could also vary with time, it could vary with, here it is just varying with the quantity, but it could also vary with time, right. A natural constraint, since we are talking of purchasing an item, not of disposing of items. So, a natural constraint then is that u k should be greater than equal to 0. Now, so what is the, if you think of what is going on here in terms of a block diagram. So, you have uh, uh, your inventory, now it gets in demand, W k, the stock at the beginning of kth period, that is x k. Then there is also the u k, which is stock ordered, at kth period, beginning. Once again, this is also at the beginning, right. then you have the cost of period k that corresponds to period k. So, that for us is going to be r of x k plus c of u k, all right. And now, with this information you then putting in this information, the system then moves to the next time period and you get to stock at period k plus 1. In the following way, x k plus 1 is x k plus u k minus w k. So, remember once again that u k has to be u k here has to be chosen without knowing this w k. Although these arrows are all pointing in at the inventory system here, remember u k has to be chosen based on x k and the past w k's, not as a function of this w k. Okay. So, now we the goal then is, now there are what is the objective then? The objective is to say, well, I want to decide how much stock should I be ordering in order to minimize my total cost. So, let us say there is also, in addition to these costs, let us assume there is also a terminal cost r of x n. This is, let us call this a terminal cost. A terminal cost is simply a cost that you would incur at the end of the time horizon that you are considering. So, when you reach this point n here at the time of the time horizon that you are considering, you have no more decisions to make. That is the time up to which you are looking ahead and taking decisions. Once you reach that sort of time that end, if you are left with an inventory of x n, what is the amount, what is the cost that having that inventory would carry. So, either positive inventory or negative inventory, what is the cost that would carry? That is what we call the terminal cost. So, our total cost then is a sum, comes up as a sum total of 3 terms. So, you have your cost of that you have for holding, you have your cost of purchase, and this cost apply, these two cost terms apply at every time instant. But then in addition, there is also a terminal cost here at the nth time instant, right. So, the total cost then, total cost that we incur is equal to the expectation of the terminal cost. So, plus the cost that you incur at each time period. So, there are these n time periods, k denoted k equal to 0 to n. The cost you incur at each of those time periods is r of x k plus c of u k, right. So, this here is the stage wise cost, a cost for at each time instant. This is terminal cost. Now, what we want to do is decide what should be these actions, okay, or what is that what we want to decide is what is the amount of stock we want to order at each time instant, at each of the at the beginning of each of the n periods denoted 0 to n minus 1, right. So, the amount of stock to be ordered is our decision. So, what you would want to do is minimize the above cost, minimize this r of x n plus this sum, So, you want to minimize this, but then minimize by choosing what? You would like to minimize this by choosing the amount of stock to be ordered at each time. Now, but if there is a little bit of a catch here, and so that is one thing I want to make sure all of you understand. So, if I write here say my action that I want to choose, which is u0 to un minus 1, while that is correct, yes, I do want to choose choose the quantity that I want to order at each time instant. The trouble with defining it, trouble with writing this here is that these quantities are to be decided based on the inventory level that we would see at the beginning of the time period. So, UK is the stock to be ordered at the beginning of the kth period, and that would obviously be decided once you look at the inventory at the kth period. And that inventory at the kth period would depend on what demand has transpired between up to that time from the start of the first period, right. So, the UK is not simply a quantity that I can decide at this right now, because it depends on the inventory that would be available, and the inventory that would be available depends on the demand that would get realized, all these demands from the previous time instance here. So, there would be previous time instance here, there the demand from those time instance would determine the inventory that would be available at the kth time instant, and the demand that would come in the previous time periods is not something that I know at the start of the problem, right. So, when I am trying to make this when I am trying to decide this problem has been posed assuming I am sitting at time period 0 and looking ahead into the n time periods that I have that I have considered. And since I am looking ahead, I do not have knowledge of what the exact demand is going to be. I do know its probability distribution, I know what kind of what it is likely to be with what probability, but I do not know what its value is going to be, right. So, as a result, because the information on which my action is to be taken, that is information based on which my stock is to be decided, the stock to be ordered is to be decided. Since that information itself is not available to me at the start of when this problem is posed, I am actually in a fix, because I do not know what action should I be planning, what kind of information I should be planning for, right. So, the value of the amount of stock to be ordered has to be decided only once we have seen the information that is available, which is the stock that is available at the beginning of the period. So, without that being provided to us, the amount of stock to be ordered is not something we can decide, right. So, as a consequence, this way of writing of posing the problem is actually not well posed. So, this is incorrect, this is not well posed, and the reason this is not well posed is because I do not have a way of even talking of the action or the stock to be ordered at time k sitting at time 0, because the information on the basis of which that action is to be taken is not available to me at time 0. Okay. So, what does this mean then? So, this means that we are thinking of this problem sitting here at the start of the time horizon. We know there are going to be demands that are going to be realized over these periods, but their value is not known to us. We just know their distributions, probability distributions. Sitting here, we want to still be able to decide what is it that we need to, what action should we be taking, or what amount of stock is to be ordered at each of the time periods, right. So, because and a specific action cannot be decided because we do not know, because that action would depend on the inventory available, and that inventory available in turn would depend on the demand that would get realized, which is not, and which in turn is not known to us, right. So, as a result of this, what do we see? We see that when we have to make these decisions to minimize the cost that that is stated over the entire time horizon, okay, a cost that is stated over the entire time horizon. This cost we cannot possibly pose this problem as a problem of deciding the amount of stock to be ordered. So, the plain and simple reason is that the amount of stock to be ordered depends on the information that will come up later during the problem itself, not at this, it is not available to us at the start of the problem. So, what is then the alternative? What is the alternative? Since we cannot, since the quantity to be ordered is going to be decided based on the information that will become available during the problem, what is the alternative? What is it that we can actually decide at the start of the problem, at the beginning of even before the demand is actually realized? The thing that we can decide is not the quantity to be ordered, but what our plan is going to be for quantities that we would want to order based on the information that we would potentially get during the course of the problem, or during the course of the time during the problem, right. So, we can decide what is the amount, how much quantity would we order if we had a certain amount of stock available at the start of the time period. That means, what we can do is not decide a specific quantity, but rather an entire plan which tells us how much quantity should be ordered for each level of stock, right. So, if this level of stock is 100 units, you would order so much quantity. If the level of stock is 20 units, you would order so much quantity, 30 units, you would order so much quantity, etc., etc. We do not know what the level of stock will be. That is something that will come up something that will get realized once the demand itself gets realized, right. But we can still plan for every possible level of stock that could get realized, and that is essentially what we are doing here. We are thinking of every possible level that could get realized, and based on that we are trying to decide what should and for each such level we are trying to decide what the amount should be, all right. So, this way of thinking about the problem then basically means that what we are looking for is not just merely an action, okay, which is an action would be simply a specific quantity that you want to order, but rather an entire plan of actions. So, the plan of actions is then a function which tells you what action you should be taking as if once you get a particular information, right. So, what we are therefore optimizing over is a function, are functions that will map your information, which is in this case the amount of stock that you have at the beginning of the time period, to the action that you want to take.